This is video 3.4.2, and the objective of this video is to be able to solve logarithmic functions, or equations, excuse me. You've done exponential equations, now we're going to look at logarithmic, and there's just a couple of strategies that you need to be aware of for logarithmic. The first strategy that you'll want to write down and get at least one example on is how to use the log loop. You've already been using the log loop, but now we're going to use it to solve in logarithmic equations. The log loop comes in handy when you have one logarithm and it equals a single number. What we're going to simply do with this first example is simply rewrite it as 4 to the second power equals x plus 3. Now we'll just solve like any other equation. 16 equals x plus 3, so x is 13. So that's the simplest case, but of course it's going to be a little more complicated than that. In the second example, now we'll have to use the fact that this is a natural log. Before we can use the log loop, let's get rid of the 3, so we have natural log alone, natural log of 2x alone, I should say. So we get natural log of 2x equals 4. Now we'll use the log loop. Remembering natural log is base e, so we'll do e to the fourth power equals 2x. E to the fourth power, we want to remember, is a number. I could calculate that using my calculator. It's 2.728 to the fourth power. So I simply have one more step to solve for x, and that's dividing both sides by 2. So my exact answer is e to the fourth over 2, and you want to leave it in an exact form whenever you can. Remember to always check your answers. Sometimes some solutions don't make sense, but we want to plug in our answers and make sure they actually do make sense. So we plug in our answer for x, solve and simplify, and quickly we can simply use the power rule to see that we get an answer of 12, because 4 times 3, once we drop that power out in front, is 12, and the natural log of e is just 1. So we can quickly check our answers and make sure that it actually does work and does in fact give us an equal expression. The third example is a little bit more complicated. It draws in on some of our properties that we've learned about logarithms. So notice there's 2 logarithms, but they're both base 2. That's good because we can simplify this and make it into one logarithm by using a simple property, the product rule. The product rule will allow us to rewrite this as a product inside of the logarithm because the product inside of the logarithm is equal to the sum of the 2 factors. And of course now we'll use the log loop by simply rewriting it as 2 to the third power equals the value on the inside of the log. Now we'll simplify a little bit here and notice that it is a quadratic. So now we're going to solve a quadratic. And once we solve the quadratic, we'll solve it by using the zero product property. So I'm going to go a little fast through this because this should be getting to be natural and a lot quicker at this point in the year. And you should simply factor at this point to figure out what the 2 solutions are. Once we factor it, we use the zero product property and see the 2 solutions are 8 or -1. The second strategy to solve logarithmic equations is using the one-to-one property. And what this really means is we're going to get logarithm of something equals the logarithm of something else. And there's only one value possible, 1-to-1. So let's take a look at how this works. We're going to start by using the quotient property because this gives us a single logarithm on the left equals another logarithm on the right. Now the one-to-one property says that these 2 values inside the logarithm have to be the same because the natural log of a number equaling the natural log of a different number, those 2 numbers actually have to be the same. There's only one way to get that inside number. Because remember, logarithms are asking for a power, and there's only one power to take e to get the value on the inside. So we simply drop the natural logarithms, kind of like we dropped the bases when we were working with exponents. Now we'll solve this equation just like we know how from past years. We'll use the cross products to get the x's out of the denominator. And then we'll solve by writing out this as a quadratic and getting everything to one side. So we're going to solve the quadratic again just like we did in the previous example. So to get what I have in green there, I subtracted 4x from both sides and I subtracted 3. Now I'll factor and use the zero product property. X equals 3 or -1. So we're going to be using some of our newer properties, but in the end it's just solving an equation once we get rid of the things like the natural logarithm. Here's your checkpoints for this video. This video was rather short, so do your best on these checkpoints, and remember to try and check your answers. Try one of the strategies, and when you explain your answer for the multiple choice question, please share to explain which strategy you used, so that I can follow your work and help you make sense of it tomorrow. In the free response question, again, explain which strategy you used, and try to give the answer in exact form. Do your best to give your solution to these problems, and bring those questions into class, and we'll go over them together.